Welcome. Today we're gonna talk common sense and Pacific Rim. Two things that do not go together. So let's begin. And there are so many good things that we can talk about. Like this shiny red button with the sword on it. They have a weapon that can cleave a category 4 kaiju from head to tail in one swoop. And they forgot they had it. Oh, aren't they brilliant? I think they should put someone who is familiar with the weapon systems in charge of the weapon systems. We could also talk about how the EMP does nothing to Gypsy. I know they say that.
Gypsy's analog.
And whatever the hell
Nuclear.
has to do with anything. But is it really? Well, let's take a look, shall we? Here's a monitor and there's a few buttons you can press. And also there's the things that you use to control the robots. A few other things that might indicate it would be a nuclear reactor is not controlled by analog devices like levers and gears. And a neural network is not analog, it's digital. Everything today is digital and everything in the future will be even more digital. So that MP would make Gypsy go sleepy bye-bye into Garden Gnome territory. Oh, we could also talk about the Chinese robot, you know, the one with 3 arms. How does the third arm move? I don't see no third appendage on any of the 3 Chinese pilots. Maybe it's some kind of vestigial thing that I missed. Them's are all very good questions that I will answer if you want me to. Let me know down in the comments. But today we are going to talk about how the robots are moving around, because there are a few different ways. They are transported by helicopters, they move themselves, and also there's something about rockets somewhere. So the question I'm going to try and answer today is, would any of this be possible in real life? And the answer is no. Very, very definitely no. If that's all you wanted to hear, then thanks for watching. and if you want a bit of context, then keep watching. Let's start by looking at the helicopters. Here we see that 8 helicopters is enough to lift Gypsy up and move it around. Let's analyze that a bit, shall we? A helicopter works by pushing air down. In order for a helicopter to hover, it would have to push the same amount of air down that it itself weighs. Now, air density changes with temperature and pressure, but a ballpark number is about 1.225 kilograms per cubic meter at sea level and 20 degrees Celsius. In the movie it looks like they are using a Chinook helicopter. It has a payload capacity of about 10 tons. I don't think that is remotely true, so I'm just gonna beef it up and assume they are using the biggest helicopter that we've ever created here on Earth, which is the Mi-26. It has a payload capacity of about 27 metric tons, which is a hell of a lot, but still tiny compared to the giant ass robots they are lifting. Let's look at how many helicopters it would take to actually hover Gypsy at around sea level. If Gypsy weighs 7,000 tons and the Mi-6 can lift about 27.8 tons, it would take about 252 helicopters just to hover Gypsy. And to put that into a bit of perspective, because nobody knows how much that is, well, 252 M26s would produce about the same amount of energy as a medium-sized nuclear power plant. And the area of the rotors would cover about this much. So let's try and play around with the numbers a little bit. Let's assume that the 8 helicopters that we see here can actually lift Gypsy, and that they are all Mi-26s. That means that each of them would have to have a payload capacity of 875 tons. That's some 30 times more than they're actually capable of. Assuming there's a linear relation between payload capacity and rotor speed, each helicopter would have to spin their rotors about 4,200 rounds per minute. That's roughly 70 rounds per second, which is twice as fast as my circular saw is going, which is ridiculously fast. Given the circumference of the rotors is about 100 meters, we would have rotor tips going at about 7 kilometers per second, which is somewhere around orbital velocities. In addition, the downward speed generated from the blades going so incredibly fast is in the area of 500 kilometers per hour. That's twice as fast as any hurricane ever recorded. It would destroy absolutely everything it came into contact with. And remember, these are the optimal circumstances when you just have to hover. Imagine what it would take if you had to actually move the robot somewhere, which they do, and that somewhere is on top of a mountain where the air is a lot less dense. The rotors would have to spin a lot faster. So to sum up, transporting giant ass robots with helicopters is a very, very, very stupid idea. So what if you have the robot move around by itself, which incidentally they also do, otherwise the movie would be rather dull. It would be 10 seconds long and look like this. And they did not live happily ever after. But how much energy does it actually take to move around Gypsy? It's about 88 meters tall, 7,000 tons, and it is powered by a nuclear reactor. I assume that the robots are roughly dimensioned according to humans. After all, they do look human-like, and they are, at least according to the movie, controlled by humans using a neural network. So, I'm just gonna use normal human motions to approximate the energy used here. So let's kick this off by looking at a normal running motion. A decent runner runs with about 180 steps per minute, which is about 3 steps per second. But looking at this clip of Gypsy running, it looks more like 1 step per second, so let's just go with that. Also, you bounce about 5% of your total height every time you take a step, which means that Gypsy would bounce up and down 4.4 meters every single step. It is now quite easy to calculate the energy of running. It is simply just to calculate the potential energy. And if you do that, you end up with about 300 megajoules per step. And since Gypsy takes 1 step per second, that is very handy, 300 megawatts. But wait, I hear you say, what about all the movement of the limbs, the arms and the legs and the shoulders and the rotation of the torso and everything? Yes, I know, the numbers are hugely simplified, but I'm doing that for a very good reason. We're not doing exact science here, we're just spitballing. We're trying to apply a bit of common sense, basically just sanity checking the numbers presented to us in the movies. Another very good reason is that I just can't be asked to do all the calculations for every single limb of the body, and I don't think you'll find it very interesting either. So, Gypsy's arm is now one big iron bar with a great big lump of iron on the end. It's an arm and a hand, and I do hope you take a second here to appreciate my artistic skills in graphic design. On a normal human being, an arm and a hand would be about 8% of the total body mass, but let's just beef it up and say 10%. I'll try not to bore you to death with all the math and calculations, so here are the formulas and here are the numbers. What you need to know is the numbers represent Gypsy holding out the arm and moving it up and down plus and minus 15 degrees from horizontal. Doing this motion every second requires about 100 megawatts of energy. Well, times 2, because, you know, Gypsy has 2 arms. And the same goes for the legs, except they weigh about twice as much, which means that they require twice as much energy. In this case, 200 megawatts. Times 2, because by sheer coincidence, Gypsy has 2 legs as well. What do you know? So, all in all, we are looking at somewhere around 900 megawatts just to move Gypsy around. Let's just, for the sake of it, say an even 1 gigawatt. And that is under the very best of circumstances. We assume that the engine is 100% efficient, there's no heat loss in the joints, and no drag when Gypsy moves around, especially in water, and a ton of other components that would increase the energy needed to move around. So the 1 gigawatt is a ballpark number, and it's a very low ballpark number. The real number is probably 2, 3, 4 times higher. Anyway, it's perspective time. How much is 1 gigawatt? And how big is a power plant that is capable of producing 1 gigawatt? Well, the biggest aircraft carrier in the world, that's the USS Gerald R. Ford, produces about 700 megawatts. That's for propulsion and every auxiliary system on the ship, and it has power to spare. Just for a size comparison, here's the Gerald Ford dinghy and here's Gypsy. So energy-wise, we are looking at around 2 Gerald Fords for every Gypsy. But how much does a power plant on the US Gerald Ford actually weigh? Well, I don't know, because for some weird reason, that information is classified. So, I don't know. Instead I was able to find some information on a nuclear submarine power plant. And more specifically, for all you fellow nerds out there, it is the S6G nuclear power reactor for the Los Angeles class attack submarine. That nuclear reactor produces about 26 megawatts of energy, and it weighs 110 tons plus 80 tons of coolant. So if we need 1 gigawatt of power, we are looking at somewhere just shy of 40 S6G nuclear reactors. Given that each of them weighs about 190 tons with coolant, a 1 gigawatt juice box for Gypsy would weigh just about 7,500 tons. 5 sanity points for the first guy who can spot the problem. Exactly. The power plant weighs about 500 tons more than Gypsy. The robots in Pacific Rim are modeled from us. The problem is that we are very inefficient at moving. We use a lot more energy than is actually needed in most circumstances to get from A to B. Cars and planes and boats are all way more energy efficient than we are. That's why we don't have huge robots walking around. Otherwise container ships would have legs and trains would have huge biceps. You can't just scale up humans and say they're made from iron and expect everything to work as normal.
It's against the Nuremberg laws.
Gypsy is not able to move by itself. So if it ain't able to walk or run, and it can't be flown by helicopter anywhere, then maybe the rockets will work. So let's try that, shall we? Let's see. SpaceX, Falcon Heavy, there we go. And it weighs around 1,420 tons and have a thrust at sea level of 22,819 kilonewton. And that is a lot. Here's a fun fact for you. It takes about half a newton to press a mouse button. So, in theory, a Falcon Heavy would be able to press the subscribe button 50 million times. That's almost half a PewDiePie. Moving on, let's assume for a second that the Falcon Heavy rocket weighs nothing. In that case, it would take about 3 of them to make Gypsy hover at sea level for around 2 minutes. Strap another one on and you would see Gypsy flying, if the rocket weighs nothing. However, if it does weigh something, which it obviously does, then things look a little bit different. Assuming SpaceX knows what they're doing, the Falcon Heavy is capable of hovering about 800 tons just above sea level. That means that 9 of them would be able to make Gypsy take off, admittedly very slowly. Slap a couple more of them bad boys on and you would see Gypsy just take off. Problem solved. And now you have a robot on a stick. As ridiculous as it may sound, I actually think that sticking 11 Falcon Heavies up Gypsy's ass is the most feasible way. That should probably tell you something about where the movie is on the Sanity scale. It's down here. Don't forget to like the video if you did, and I'll be seeing you in the next one.
Hey, come on! We're being deployed.